Right, this is the first of the lectures and instructions for week 15 in Intro to GIS. Remember that we will be meeting asynchronously. Please use these videos to understand ideas of point patterns that we began talking about last week and to work through some examples of how we would use point pattern analysis. All right, so this week what you're going to be doing is you're going to be working with densities in a vector environment and in a raster environment, and then we're going to be doing some very basic statistical analysis of the distribution of points in space. That is our phenomena. So again, we're going to do spatial joins to produce density counts in enumeration units, point density, kernel density, and then we're going to be doing nearest neighbor, clustering, and hotspot. And all of these are relatively straightforward once you get your map set up. So let's get started. Describing point patterns. Remember, and again, this is for the final exam, that we can think about point patterns in 4 different ways. And I want to look at the 2 extremes. We talked about this last Thursday, but I want to reiterate that. If we think about the extreme of clustered, all points lie on or nearly on the same location. That is a very concentrated event. And we can imagine phenomena where there is something, some factor controlling the concentration of these phenomena. In a kind of the opposite scenario is what we would call the regular distribution, in which the points are the maximum distance from all other points. And if you look at this, what you can see is that this point is the maximum distance from this one, and from this one, and from this one. Okay, and the same thing we could say here, the maximum distance to each one of these. And so we kind of have this hexagonal pattern. Now, outside of that, we can see something that we would call a normal distribution around a center. And what we see here is literally what we think of in normal distributions. That is, within a central area, the highest concentration of points occurs, but the count of points decreases as we go away from that center. And so again, you can imagine it literally like a 3-dimensional normal curve, that as we go farther out, fewer and fewer points exist. Now, the alternative to this, and understand, this is not random, this is normal. A true random, and by the way, we call this a true random or CSR distribution. Okay, this is a complete spatial random distribution. And in this case, there is no statistically significant underlying concentration or distribution of the points. Okay, so again, clustered to regular, normal to random. Okay, 4 ways of understanding points. Now the reality is that if something is truly random in space, it's not terribly interesting to us because nothing is controlling its distribution. But we do use random as our null hypothesis oftentimes in describing whether something is concentrated. In other words, we have, for example, crime that is occurring in a very clustered area, a normal distribution that is the distribution of some event based on an area. Yes, there is control of it, but that influence decreases over distance. And then a regular distribution where there are truly some factor that repels individuals from the other events. All right, so one way we're going to look at this is in a vector environment where we look at the number of events per enumeration unit. So for example, how many Bigfoot observations occurred per county or per state. Because states and counties have different sizes, remember we're going to do it per unit area within that enumeration unit. So again, basic idea here is we're going to determine the area of each enumeration unit. We're then going to perform a spatial join of our points to our areas, our polygons, and that spatial join is going to give us a count per enumeration unit, and then we're going to normalize that by the area. So what you want to get, my end results if you will, you're going to go through these steps. Number 1, we're going to make sure that our map and or our data are in projected coordinate systems. We're going to calculate an area field. We're going to do a spatial join with the area features, that is the counties, as our targets. And then we're going to symbolize the data by the join count with area as normalization. And again, what I want you to turn in is a screen capture of your results. Okay, so what we're going to be doing now is we're going to be doing this process. And again, a couple of steps here. We're going to begin with our enumeration unit. So here's my county boundaries. And what I want to do next is I want to calculate a new field or create a new field. So I'm going to right click and I'm going to open up my attribute table. And again, so here's my attribute table. We have these here, but we need to calculate a new field. And so what I'm going to do is I'm going to right click here and I'm going to go to my field view. And now what I'm going to do is I'm going to go all the way down to the bottom and I'm going to add a new field. I'm going to click on that and I'm going to do area underscore SQKM. Now I want this to be double because I want to have decimal places. So I'm going to double click here and I'm going to go to double. Okay, so I've got a new field and it's a double precision. You'll notice up here I need to click save. So I'm going to do that right now. I'm going to click save. Now the other thing that I want to do, to be perfectly honest, is I want to get rid of some of these fields in terms of their visibility. So I'm going to click this off. And so all I really want to be visible here is my area in square kilometers. And I'm going to go all the way up here, and I want the name and the state name to be visible. Those are the ones I want. Now I'm going to go up here and click save. Okay, so now when I close this, you'll notice that I have area in square kilometers, the state name, and the name of the county. The next thing I'm going to do is I'm going to right click on area in square kilometers and I'm going to click calculate geometry. Click on that and I want this field, area in square kilometers, and what do I want? Well, I want its area. And I'm going to click on area geodesic. The next thing I need to tell it is its area units. I'm going to click the drop down and I'm going to select square kilometers. Now, I'm going to leave it in its native coordinate system. I don't have to actually put anything in there. And now I'm going to click Run. All right, so we've got our area now here. The next thing that I'm going to do is I need to do a spatial join. So I'm going to close this. And I'm going to go back to my Bigfoot observations, and I'm kind of going to do the same thing real quick just because it makes my life a little bit easier. I'm going to click on my attribute table and my field view. And to be honest, I really don't want to see much of this. And so I'm going to just leave my object ID. You'll notice is automatically on, doesn't matter. And I'm going to leave everything else off. I really don't need any other information. It just makes for a bigger table. So I'm going to turn that off now, and I'm going to click Save. Now I can close that. And so now I don't really have any information there, but I will get information in my next step. So the next piece, I'm going to go back to my county boundaries, and I'm going to right-click, and I am going to do a join. In this case, I'm going to be doing a spatial join. I'm going to click on the spatial join. And my county boundaries are my target feature. My join features are going to be my Bigfoot observations. I'm going to leave it as 1-to-1, and I can really leave everything else the same, and click Run. Now what I get out of this is a county boundary with spatial join. Now if I right-click on it and open its attribute table, what you're going to notice is I have a join count now, and I have an area in square kilometers. The join count is in fact the number of points in each enumeration unit, or county in this case. So now I'm all set. I'm going to close that, and now what I'm going to do is right-click, go to my symbology, and instead of a single symbol, I'm going to do graduated color, join count, but now I'm going to normalize it by area in square kilometers. Okay? And so now this gives me my area in square kilometers as the normalization. In other words, each of the counties is the same, and it's the number. So again, we have a density. observations per square kilometer in each county. So we're all set. So again, join count by area in square kilometers. That's our map, and that's what I want you to do a screen capture of. That's what you'll be turning off in for the first part.